Okay, I would like you to pause the video really quick and try to do the bell work on your own, and then when you're ready, play the video and check your work. So hopefully you drew a right triangle. The hypotenuse here is representing the ramp that's 29 feet long. The base, it says, is 26 feet, and you are trying to find how far above the ground it is. So since it's a right triangle and we know two of the three sides, we're going to use Pythagorean theorem to solve for the missing. Now we're solving for a leg here, so I'm going to substitute that in there for A, 26 in for B, that's the other leg, and then the hypotenuse is 29. So we always need to square the numbers first. So go ahead and put those in your calculator. X squared plus 676 equals 841. We are trying to isolate x squared, so subtract 676. And then you just need to square root both sides. The square root of x squared is x, and then the square root of 165 is about 12.8. Since this is a real world type problem, we're not going to leave it as a radical because you wouldn't say that in a real world situation. So we'll say that it's about 12.8 feet above ground. All right. So today we're going to learn about special right triangles, and when we solve those, we're going to use some special patterns. So it's just a different way to solve right triangles. Before we can do that though, we need to know how to do something called rationalize the denominator. This is going to happen, and you're going to have to do it when you're simplifying radicals or simplifying fractions that have a radical right here in the denominator. So when simplifying radicals, we cannot leave a radical in the denominator. In math, we just say that it's not proper to leave our answer like that. So to get rid of the radical in the denominator, we must do what's called rationalize the denominator. So you're going to do this anytime you end up with an answer that's a fraction that has a square root in the bottom. So let's try it. The first one, let's say I do my problem and I get 5 over the square root of 3. Well, I'm not going to leave it like that because that's not a proper way to leave my answer. So to rationalize it, you take the radical that's in the denominator and you multiply it on the top and on the bottom. Now, square root of 3 over square root of 3 is 1, so I'm not changing the value of this. Then to multiply fractions, we multiply top times the top, bottom times the bottom. Those are both in square roots, so you can just multiply what's underneath. 3 times 3 is 9. Well, that gives me a perfect square. So I can simplify this a little bit more. The square root of 9 is 3. So what we've done is we got rid of the radical in the denominator. This will be the answer that I want. It's rationalized. There's no more square root in the denominator. So why don't you try this one, pause it, play the video when you're ready. So we're just going to multiply by the radical top and bottom, multiply straight across. Those aren't like terms, so you can't multiply the 10 and the 2. These are like terms. 2 times 2 is 4. Square root of 4 is 2. Now this one we can go a step further because we can simplify these numbers here. 10 divided by 2 is 5. You just want to simplify it as much as possible. So again, try this one over here on the left. Pause it, play it when you're ready. So multiply by root 3 top and bottom. 7 root 3 over 3 times 3 is 9. Square root of 3 is 3. 7 over 3 would get you a decimal, so we're just going to leave it. Now this next one's a little bit different because it has a radical on the top and the bottom. So we're still going to do the same process. Except this time, since those are both in radicals, we can multiply them to get square root of 50. Square root of 5 times square root of 5 is square root of 25. Square root of 25 is a perfect square. Now we can actually simplify the square root of 50 a little bit. Factors of 50 that are perfect squares are 25 and 2. The square root of 25 is 5. 5 divided by 5 is 1. So that's just root 2. All right, notice here we have a number and a radical. Doesn't matter, you're still just going to multiply by the radical, top and bottom. So we've got 4 root 2 over 3 times root 4, because 2 times 2 is 4. Simplify what's down there. Square root of 4 is 2. So that's 4 root 2 over 6. Now 4 over 6 can be reduced. 2 goes into both of them. 2 goes into 4 twice, and 2 goes into 6 3 times. All right, last one, very similar to the first 3. Pause it, try it on your own. Multiply by root 3 top and bottom. You might have already seen the pattern. You don't have to show the step where you get the perfect square. You can just know root 3 times root 3 is 3. That happens every single time. And then 6 divided by 3 is 2. Notice that we never changed what was in the radical there, because those aren't like terms, so I can't divide by what's in the denominator, so make sure you leave it just like that. So in the next few videos you're going to watch, you're going to have to do this process if you end up with an answer that has a square root in the denominator.